In this gas distribution device, you will got totally 8 line gas flow control identically. You can choose to use either one by the ball valve is installed at the bottom. When the ball valve is vertically to the flow meter, the line is closed. When it comes to horizontal with the flow meter, that line is open. Then you can use this valve to increase and decrease the flow. The flow can be controlled based on the value indicated here. If you don't have high accuracy, you can base on this original calibration, which done based on air. But if your gas that have different densities with the air, and also at the same time you have a high accuracy, you can do the calibration with soap bubble flow meter to get the real factor for your flow meter. Normally, if you use same based on calibrate with air, is enough for your common application. When the gas was in from the bottom, then come out from the top, you can connect to the flexible tube that we prepare for you, and at the same time you can use this device for you to adapt from the tube into your glass device. This glass tube is that you give to me for measuring the size. And you can see this Teflon device is specially made based on your size. So you will install one of the O-ring to seal your glass device and screw into this device. Then your glass device will be locked properly without leakage. And another side, you use this O-ring to seal the flexible tube. At the same time, you screw in, you will got adapted the structure like this. In the gas flow control, we have two different type control. First is you control your device by pressure, and another you control device by flow rate. In our case, you are applied the gas flow control under atmosphere and controlled by the flow. Your target is controlled by the flow rate. So unless your device can provide the flow rate with constant measuring indicated by the flow meter, you don't need to control the pressure inside the system, because your pressure inside provides the flow that can conquer the atmosphere. In fact, based on my experience, you don't need to provide very high pressure. Normally, you give a 0.1 to 0.15 megapascal. It's more than enough to provide enough flow rate, even for totally 8 flow rate when you are using. Because higher the pressure that you provided cannot help anything. That is only make your control become difficult. Pressure in the whole system is only atmosphere, so you don't need to conquer high pressure to reach the flow rate that you needed. You just need to provide based on the indicator. So don't send the pressure too high. Too high will provide less help, and the pressure will only locked before the ball valve. That make your pressure before going higher. Of course, if your device like what we're doing is installed with the high pressure foldable tube, it will have no risk. But sometimes, like your old device, you are using not very professional tube connections, high pressure gas resources may be lead to strong leakage as what the problem you face. But when your system is based on pressure control, that means you have a pressure controlled device that you need the pressure inside the system to be maintained as a predict value. At this moment, you can give the pressure at the regulator side is about 10 to 20% higher than your inquiry. For example, if you would like the pressure inside to be controlled under 0.1 megapascal, you can choose to give the pressure resource at about 0.12 megapascal, but also not too high. Too high is not easy for you to control. Just enough for use is enough. For controlled pressure or not controlled pressure is dependent on your system inquiries. It's some kind of definition related with neat pressure or related pressure that is dependent on your experimental inquiry. You can choose to control or not control based on the standard method or the experimental design that you are required. But for the total amount of the gas that provided into the system, of course, it's related with the pressure that controlled, because the total molar of the gas molecules is related with the pressure that provided into the system. For example, the total molar under the same flow rate that you provided into the system under the higher pressure is more than the one that you are provided under the lower pressure. So if you calibrate based on the molar rate or the molar values that you need to be considered pressure, then you need to specify whether the pressure you are talking about is a neat pressure or a related pressure. So any problem about the pressure related with the flow rate, you can call us for more consultants. That's all for your system.